Hello guys, welcome to the Techogenius Academy. We are the training providers who wants to build their career in Linux, device drivers, build Linux, data science, machine learning, IoT and artificial intelligence. So today we're going to discuss about the next session on Linux system programming. So without wasting any time, let's get started. So today we're going to discuss about the thread synchronization. Earlier we have discussed thread management, how we can create the threads. So today we will discuss how we can synchronize between the threads. So thread synchronization is a mechanism where two or more processes or thread do not simultaneously execute some particular segment, which is nothing but a critical section. In easy words, suppose a particular thread access a critical section or a shared segment which is controlled by the synchronization techniques. We have discussed semaphore also. So in this thread synchronization we can use mutex. Suppose in mutex you have one thread which is doing one task or some accessing some shared resource and all. In that there will be other threads also which is sharing that a critical section of code. So if you are not synchronizing these threads properly, it will may cause the race condition. What is that race condition? It's like you the value which you are the shared resource, the critical section, the value you are accessing, it will give you unpredictable value. Okay, so for that reason we are using thread synchronization. So in thread today we will use mutex. So we have discussed the thread. What is thread? Is a lightweight process. We have discussed the advantages, disadvantages, what are the functions we can use in threads. We have discussed and all. So in this we will discuss about the mutex. So going further, I just want to explain you through program. So what I will do, I'll just write some sample program to make you understand why we are going for thread synchronization, why we are going for mutex and all. So we'll go to our folder cd threads. Yes, we have thread test.c. That's it. So now we'll include here our header file, header.h. We have used it in our earlier programs. So now what I will do here, I will just create two threads, pthread underscore t thread id 1 and thread id 2. pthread create address of thread id 1. We can pass null here, and here we can write our function thread function 1, and you can pass here null. That's it. And we can create pthread other thread underscore id 2. We can pass null here. Thread function 2. So pre-thread join will wait for other subthreads to complete. Thread id 1. So if you don't pass null here, you can use the string which will come from pthread exit from other subthreads. So you can have exact idea that your thread is completed and it came to the main thread. That's it. So now what we will do here, we will just create thread function 1 void pointer some p, and we can just write printf thread percentage %d has started. Here we can use some count value, and we can write here thread percentage %d slash has finished. This I can so count plus equals to 1. I can just declare here equals to 0. That's it. And what I will do, I'll just copy this same function this looks good to me. We can pass return also. Or pthread exit 2. cc thread underscore test dot c hyphen o thread underscore test hyphen lp thread. Yep. Thread underscore test. So you can see here thread 1 has started, after that thread 2 has finished, and then wherever thread 1 is gone. Okay, so this is not proper. So as you can see here, first thread 1 has to finish, after that thread 2 has to finish, then only it will come out. But in this way you can see here we are not getting the proper value. So for that reason only we are using Mutex. So what I can do here, okay, so I'll just create some another program, thread underscore mutex dot c, yeah, hash include header dot h, okay, int main p thread underscore t, thread id 1, thread id 2, printf creating thread 1, pthread create address of thread id 1. The same thing I'm doing here. I can use some sleep here. Printf creating thread 2, there is no need of this. I can use join, okay, this looks fine to me. So now we need to create the object for that mutex. So static pthread underscore mutex underscore t. Yep, we can use here mutex, or you can use log2, anything you can use. So void star thread function 1 void star p printf thread function 1 okay. So what we can do here, we can use some sleep here, and we can print 2, thread 1 is sleeping, great, and printf came out from thread 1. Turn null here. Okay, for other thread underscore function 2 void star p or some q thread 2 has started. I can say I can use sleep, some sleep here also. Thread 2 is sleeping. Is finished. Okay. This looks nice to me. So now we need to use the lock here. So without I can just explain you the functions. So mutex we can use as of two types, locked and unlocked. At most one thread may hold the lock on mutex. It means like if you have multiple threads and all, if one thread is requiring the mutex, so it will complete their work, and after that it will unlock, then only it will go to other thread, and the other thread other mutex and all other thread will keep on waiting over there. It will go to sleep. So when the thread locks a mutex, only that mutex owner can unlock the mutex. So if we are locking, we that thread will unlock the mutex. Other thread or other mutex will not unlock that particular thread. The following protocol for accessing the shared resources: lock the mutex for that shared resource, access the shared resource, unlock the mutex. Okay, so we'll try to write some shared resource. I'll write to try some values and all, so you can have a better idea. Create a mutex referenced by the mutex with the attribute specified by the attribute. If the attribute is null, then the default mutex attribute is non-recursive. That will be non-recursive which is used. Okay, so how you can initialize the thread by using pthread underscore mutex underscore init. Okay, how you can lock the mutex, you can use pthread underscore mutex underscore lock. How you can how you can unlock the mutex object by using pthread underscore mutex underscore unlock. And you can also destroy also. If you are initializing, you need to destroy also in the main thread. So what we will do here, so we have already created this mutex object. So now we'll just initialize the mutex init object, and I can pass null here. Great. So we need to destroy also. If it will come from the pthread join, if it success, if it will come from the other subthreads. If all the subthreads are finished, then it will come to this last call, which is your destroy function call, pthread mutex destroy. We can use return 0 here. Okay, so in this we can use the lock and the unlock thing. Okay, thread function 1, we can use here pthread mutex lock the same here we need to use. For unlock, we need to use pthread underscore mutex underscore unlock. Yes, this looks fine to me, so I can just run it here. cc thread underscore mutex dot c hyphen o thread underscore mutex hyphen lp thread. That's great, we don't have any errors. So now creating thread 1, thread function 1, thread 1 is sleeping, and creating thread 2, thread 2 has started. So thread 2 has started, now it is waiting over there. After the completion of the thread 1, it came out from the thread 1, I have printed over there, and after that thread 2 is sleeping, and after that thread 2 has finished. Okay, so this came up. So now you can see here, when our first thread is completed, thread 2 is waiting over there, okay, to complete their work. So suppose we want to access some shared resource. Suppose in world, like in the IT industry, if you are working on some project where you are using this thread synchronization, thread management, because in IT industry most of the people in most of the projects the people are using this thread synchronization mechanism. And in that, if you're working in some IoT, if you're working on some device drivers, if you're working in some user application, in the application which is in which Linux is used, okay, so in that, suppose you are accessing some temperature value, or if you are accessing some location, GPS location, if you are accessing some humidity, so you need to send the updated temperature value to the server and all. Okay, so if your thread thread, you have written multiple threads here. Suppose one thread is accessing some value, it is like the thread thread is doing some work and all, and after that your other thread is also doing some work, and it is accessing that same shared resource. Okay, so in that, if you are not using the synchronization, you can get some unpredictable value. For that only we are using this mutex, this locking mechanism. Okay, so to give you the better understanding, so what I will do, because I have not connected any embedded board, so there is no device and all. So what I will do, I will just write some value over here, some shared resource, so you can have a better idea. Static int some value, it's some, suppose some temp value. Okay, so this you will get it from somewhere and all. This temp value will be in float or double and all. So I'm using some internally just to give you some scenario like how this mutex are working and all. So here I'm using count equals to some 8 value. Okay, so what I have used temp value, sorry, here I am using temp value equals to some 10. Great. So now I can print it down here, printf the final value or the final temperature value is equals to some temp underscore value. So this looks fine to me. Just suppose, okay, I will not use this mutex. So suppose like you have not used any mutex, you are just creating some threads and all. So one first thread 1 will create, it will go and check the temperature value and it will send to server and all, what will be the value and all these things. So in the main thread you will get the final value. Okay, so after that thread 2 will execute, it will check and it will update the temperature value and it will sent to the server and you will get it in the main thread. Okay, so the final value you will get it is like 10. Okay, so we'll see like what will be the final value you will get. Thread 1 is sleeping. Okay, thread 2 is started and thread 2 is finished also. Okay, and the final temperature value you got is 8. What we were expecting 10. Okay, the other thread. Okay, but we have not used mutex here. What is happened here, thread 1 is started. Okay, and that only the thread 2 has also started. Okay, it is doing their work and it is getting the values and all, and thread 2 has finished. Okay, but thread 1 is, suppose the other thread is working, is doing their work and all. Okay, and it has changed the value. We were expecting the latest value from the second thread in from the, but we are getting the other value. So to have the exact value, we will use mutex here. Just see it very correctly, very properly. Creating thread 1, thread function 1, thread 1 is sleeping, thread 2 has started but it is waiting over there. So now came out from the thread 1, thread 2 has finished, the final temperature value is 10. So you got it. So thread 2 has started over there. Okay, but what is happened over here, it is waiting for thread 1 to complete. Okay, thread when it is completed, mutex is unlocked and it came out from the thread 1, as we can see the print here. Okay, and after that thread 2 is doing their work and all, whatever the temperature value. Actually I'm sleeping, I'm using sleep here, I'm doing my work, I'm just assigning the value, the temp value, some hard code value and all. But in the real world you are getting some temp value or some location value, some humidity value and all, and you are storing into that shared resource, some critical section. Okay, and you are coming out from that sub thread and you are in the main thread, and the final temperature value what you got from the latest thread. Okay, so the other thread, the second thread, is waiting over there to complete the work and all. So in this way you can use the synchronization technique. Okay, this is the just a sample and all. So uh, what you will try, you can use some structure over there. In main thread you can just write some in structure you can use some arrays and all. In arrays you can use some random value, you can use rand function over there, and in whatever the random value you will get, you will just add into some add into that array. You can use the sum also. So try to play around these threads and all, so you can have the better idea. So my role is to explain you the understanding of why we are using mutex here. So the question will arise, we can use semaphores too. Why we are not using semaphore? So there is a slight difference between a semaphore and mutex. A semaphore is a signaling mechanism where we use wait, where you use signals and all. But mutex is a locking mechanism. So in a semaphore, we are using integers. If you remember, we are increasing. We are trying to increment the integer, that sem value and all, the integer value. But here we are playing around objects. So mutex is nothing but it's an object. Okay. So semaphores is like it'll be categorized like a counting semaphore, binary semaphore. But in mutex there is no category. Mutex is like logged and unlocked, that's it. Okay. So you in most of the interviews also, the interviewer will ask you like in which scenarios we can use semaphores, in what scenarios we can use mutex. So you can have that particular idea in your mind, like in whatever the scenarios you can use this synchronization techniques. Okay. So hope you like this video. Please don't forget to like, share and subscribe, and we will come up with the more Linux system programming concepts. So thank you so much.